Hello everyone, and welcome to the Forestry Adaptation Community of Practice webinar today. For those of you who don't know me, my name is Annette Morans, and I am the facilitator of the online adaptation communities of practice, which are run by us here at OKR, which is the Ontario Centre for Climate Impacts and Adaptation Resources. And I'm sitting here with my colleague Alison Miles at the OKR office located at Laurentian University in Sudbury, Ontario. So today's webinar is the first of a two-part webinar series titled Tree Vulnerability to Climate Change and Implications for Adaptive Silviculture. So this webinar series will describe recent advances in the quantification of the three components of forest vulnerability to climate change, so exposure, sensitivity, and adaptive capacity in Canadian forests, and will discuss their implication in developing climate-friendly silviculture practices. So the way this webinar will run is as follows. So after this short introduction, we'll have the main presentation, which will go for about 40 or 45 minutes. And then at the end of the webinar, we'll have some time for a Q&A session. But before we get going, I just have a few housekeeping items to go over. So first, for those of you who dialed into the conference call line, your lines have been automatically muted. And the reason for this is just to avoid any audio distractions or feedback during the webinar. So if you prefer to ask a question over the phone during the Q&A session, all you're going to have to do is dial *6, and that will unmute your phone line. But please do keep your lines muted during the presentation. And although we will have a dedicated Q&A session at the end of the webinar, that doesn't mean you have to hold your questions until the very end. So as we go through the webinar, please feel free to type out your questions in the chat box area on the left, but just note that we will address those questions at the end. Also, if you have any technical difficulties during the webinar, please just hover your mouse over my name and the attendee list and click on Start Private Chat, or you can also email me, which is in the chat box area there as well. And I do want to mention that we are recording the webinar today, and I'll be sending out a copy of the recording to all those who have registered for the webinar. And finally, I know we have some people on the line today who may not be familiar with what the Forestry Adaptation Community of Practice, or the FACoP, is. So I wanted to take this opportunity to quickly mention that it's an interactive online community dedicated to those who are working in forestry or who are simply interested in forestry and climate change adaptation in Canada. The FACoP is made possible with support from the Canadian Council of Forest Ministers Climate Change Task Force, and it includes features such as an online resource library, news articles, discussion forums, upcoming climate change events, and more. So it's free to join. If there's anybody on the line today who's interested in learning more, please click on the link in the chat box for more information and to register. So with that being said, we are very excited to have Isabelle Aubin on the line with us today to talk about an integrated assessment of Canadian forest vulnerability to climate change. And just so you know a little bit more about your presenter, Isabelle is a research scientist in vegetation ecology with the Canadian Forest Service at Natural Resources Canada and is located in Sault Ste. Marie, Ontario. She's also an adjunct professor at l'Université du Québec en Ottawa and at Sherbrooke University. The central questions behind Isabelle's research are the impacts of human-mediated disturbances on forest ecosystems, with a focus on the application of ecological theory to practical problems in forest management. So on behalf of everyone joining us, I'd like to extend a very warm welcome to you, Isabelle, for taking the time to present this webinar for us today. It's very much appreciated. So without further ado, I will now hand things over to you.
Thanks, Annette, and thanks everyone to take the time to listen to this seminar. I'm really happy to have this opportunity today to talk to you about the work we're doing preparing the presentation in the last weeks. I just realized that now it's 5 years that we're working on that project. So we're starting to have quite a lot of things to share with you. So when I say we, it's very important for me to start with that, to telling you that all the work I'm presenting here is the title is that Integrated Vulnerability Assessment. So we are really integrating the work of several people. So we are a large group of people working. There's the people from my lab, just here. These are people from my lab, but there's also all the people that you see in this slide that are collaborators or co-authors of some part of the work. So this is really a collaborative work, and this means we are integrating a lot of different expertise. You will see it's a huge subject that we're working on. So integrating the information, I would say it's really exciting to work with this big group of people with such a wide expertise. But also the downside means that I don't have all the answers to your question. This is quite sure, you will see, because I will need sometimes to tell you, I will have to ask my expert for some of your questions probably. So, but just to tell, yeah, you will see with the presentation why you see how wide is the subject and why we cannot know everything about everything. So just to start back, how this project is structured, I think it's vulnerability assessment. There's a lot of different ways of working on that, and we have our kind of a specific way of doing it. So I will give you a bit of background on how we have developed this work. So the vulnerability includes three main factors. There's the exposure, which is the degree of environmental change a species will experience with the climate change. There's also the sensitivity, which is the degree of sensitivity of that species, so which means the degree to which a species is likely to be affected to an environmental change. And exposure and sensitivity is what you use to see what is the potential impact of the environmental change. But this potential impact is modulated also by the adaptive capacity of the species, which is the ability to accommodate or cope with these these impacts. So the vulnerability is the function of the sensitivity of the species, its exposure to environmental change, and its capacity to adapt to those changes. So just with this framework in mind, you can see how wide is the information we need to integrate to have a really holistic view of vulnerability. So exposure was the first factor that had been studied for the impact of climate change. So exposure is quite well predicted. We use climatic variables. I'm sure you're aware about some climatic envelope model, with which we are able to provide solid information on the degree to which a species is likely to be exposed to climatic change. But so if you look on the map the map that is here. This is work from Dan McKinney et al. With this map, what you can see, you have here the dark line here is showing you the current climate range of sugar maple, and in gray is what you can see, the zone in the area in gray is the future climate range that have been projected using climatic variables. So this is telling us that in gray is the projected suitable suitable habitat for sugar maple. But this doesn't mean that sugar maple will be able to shift this range to there. So to know that, we need to know about the sensitivity, some information about the ecology of the species, is how sugar maple is good to migrate and how long it will take to migrate. And also with this information, this climate envelope information is not telling us also the capacity of species to persist in place, which is really related more to the adaptive capacity of the species. So a missing piece in our current vulnerability assessment is the ecological knowledge. We really have to find a way to integrate this ecological knowledge on species sensitivity and on adaptive capacity to the biophysical prediction, where we are quite good. So the current presentation today will be on the work we've done in the past 5 years to document and trying to integrate sensitivity to exposure assessment. And next week, there will be a talk by Samuel Royer-Tardif that will speak about the adaptive capacity, which is really, would say, the next frontier. So a bit about the approach we use to document the sensitivity of the species. We're using a trait-based approach. What it is, it's based on traits. Traits are characteristics that are measurable on an individual, and these characteristics are characteristics that will respond to an environmental filter or that will affect the ecosystem processes. It's characteristics that affect ecosystem, that have an impact on ecosystem processes. So, for instance, you can think of what would be a trait will be seed size, the height of a plant, the specific leaf area of the leaves of the trees or the plant. So when you're working with the trait-based approach, you're more interested in the ecosystem function. So you are looking how, for instance, if you think of drought as one of the stressors, you're looking how this environment, when you're looking to seed mass as a trait, you're able to understand using seed mass how the species will react to an environmental filter, but also how the change community will bring differences in how the species will being able to affect the function of the system if there are change in composition in the community. So with this approach, you're really more linked to you have a language, a common language, because all species have a height and have a seed mass. And with this, you're able to have a common language to understand which species will be favored or unfavored by change in their environment, and how this change community will affect the functioning of the ecosystem. So when we think more of climate change and species response to climate change, using this approach, we can think that an individual tree species will vary in their ability to tolerate, adapt, or move after a change in their environmental condition. So the size and nature of the response of the species is expected to be quite variable, but also will depend on the characteristic of the individual species. And using the trait is really an approach that is helping us to have a quantitative assessment of the differential sensitivity between the species. So you can think that all species will respond to this environmental filter. Some species will be favored, others will be unfavored, and what will explain this difference between the species will be their traits. So at the start of the work, starting with this approach in mind, we started to try to identify which traits and mechanisms were really important for assessing sensitivity of species. So we have started with a workshop where we have invited, it was a multidisciplinary workshop where we had ecophysiologists, population geneticists, community ecologists, and mothers. We all work together, trying to develop a framework to quantify the sensitivity of species, and we try to identify the key metrics and proxies and the way forward to develop this information and make this information, this data available as well. And there's a publication, if you're more interested in this aspect, you can look to this publication in Environmental Reviews. That's really giving us, for us, it was really the framework on which we built the other pieces of the work. So then, from there, having this framework in mind, we were then able to document species sensitivity to drought. So what you have here, so I'm just taking the little green arrow. So here, this rosette here is the framework for, this is an example for drought sensitivity. And under this framework, so we have the drought sensitivity for avoidance, resistance, and recovery. So these three main mechanisms, these are the three main mechanisms under which the species will respond to drought. And then we have identified the key traits that we can use to really quantify the species' ability to tolerance to drought. So what we can see, we wanted to document all the traits that are not all the traits, but the main traits that could really be used to assess species sensitivity. Even traits for which we currently don't have enough information to be used to develop an index, but at least to know that this is a key trait for this to assess sensitivity. So that's why you can see, for instance, here carbohydrate storage here is in gray. So all the traits that are in gray in this rosette are traits that are of importance, but for which right now we don't have enough information to document, or that so we cannot use it right now in the index, or that the relationship is too complex to use it. The relationship between that trait and the sensitivity the species sensitivity is too complex to be able to model this for this purpose of developing an index. So we thought this was really important because this is a gap analysis in itself, and it's telling us where we're missing information to get further in the development of more and more refined vulnerability assessment. So having this step, so what we've done, we have documented. If you look on the right part of this slide, you can see a heat map telling you which is documented for each species. This is an index of avoidance to drought, resistance to drought, and recovery to drought. And in this, you have two columns. The first column is the index in itself that has been calculated. It's calculated with the traits. It's a quantitative index, and then so the dark red is high sensitivity, and the pale rose is low sensitivity to drought. So the species are ordinate under these different indexes. And then on the second column you got is the confidence level of this information. We thought it was really important to tell because for some species we have only very minimum information, and for other species we have quite a lot of information. So we thought again that it was really important to have a gap analysis to showcase where we are confident in the information and where we're missing information. So this is really can guide future research to document where we are missing information. So that's really important to refine the work. So this is we've done this index for species sensitivity to drought. We've done the same work for species sensitivity to migration failure, or we can say the migration capacity of the species, which again we have developed first a framework, identify the traits that are of importance, and then we have documented, and then you can have on the right, that's what it gives. You have three main mechanisms that we're looking: reproductive capacity, dispersal ability, and resource specialization. We've done the same work as well for the capacity of species to cope with increased fire recurrence and intensity. So the same approach here. And then this work, just this documentation we think it could be of use for really informative because it helps to understand under which mechanism a species is sensitive, and then it can guide on how we should manage that species in face of climate change. Just to give an example, because the species vary a lot in their way they are sensitive, they can be really sensitive under one mechanism, but not under another. So just to give and this makes really hard to develop a catch-all index of saying this species is vulnerable to climate change or tolerant to climate change. It's really hard. So it's best, I think, to capture these variation, these differences you have among mechanisms. I think it gives a better understanding, and it's easier after to manage those species. It gives information for management. So we're just giving a really simple example here with trembling aspen. If you try to make a catch-all index, is trembling aspen a species that is sensitive or not to climate change? It's hard just to make a generalization like that. Even if you think of drought sensitivity, you can find some index that will say that trembling aspen is really sensitive to drought, and you have other index that will say that they are really tolerant to drought. It depends on what you're looking for. Because if you're thinking in terms of mature stem, yes, trembling aspen, mature stem are really sensitive to drought because they have a really superficial rooting, and they will have dieback die back really rapidly after drought event. But they have a really good recovery with the vegetative reproduction. They will recover really fast after a drought. So in terms of persistence, the population will persist in the site, and in this sense, it have a low sensitivity to drought. So it all depends which aspect you're looking. Are you working at the population level or working at the stem level? Adult stem versus seedling stem, you will have really different sensitivity level. So if you think again on migration capacity, Aspen have a high migration capacity with this large seed production and short time to maturity and wind dispersal, combined with the vegetative reproduction. So we can see this is species that will have a good migration capacity. And in terms of adaptive capacity, I will not speak too much about that, but I think it's just to say that this is because Samuel will speak about that next week, but just to say that's another aspect that is really important to take into consideration about the persistence on, in situ. So trembling aspen is having a good adaptive capacity as well. So if we just contrast with another species, let's see with the red hickory, that's a species that's having a low drought sensitivity because it has a deep rooting. So that's not the first species that will be affected by the drought, but it's a species that is having low migration capacity with a low production of seeds and late maturity. And it's a species that we are lacking information about the adaptive capacity. We don't have information to be able to assess its adaptive capacity. So when you take all this information together, this can really inform management decision because you can identify with these information about how species react to these different mechanisms, you can identify which species require management consideration. When you have a species that is having good persistence ability, good migration capacity, and good adaptive capacity, the species that need minimum intervention, they have low sensitivity. But when you have a species that's having good migration capacity but not good for persistence in situ, you may think that the strategy will be to increase connectivity in the fragmented landscape. On the other side, you can have species that are really good to persistence side but have really low migration capacity, so you can focus more on the conservation in its current habitat. And using the same approach, you can identify a species with high sensitivity, which species that might be the priority in conservation plan and candidate for assisted migration. So species vary in their sensitivity to climate change, but also species vary in their exposure to climate change. Here we're presenting, this is really a short piece of a longer table that you can find in our paper in Ecosphere. I just wanted to show you for different species, even species from the same genus, you have really difference in the exposure of the species. When I speak about exposure, I'm speaking more about how the species. Sorry, I'll just take a sip of water. Yes. So the exposure of species is how much of in this case here, we're looking how much of the area of the range, distribution range of the species is projected to be affected by drought, which we have calculated that by drought or by important change in the climate inflow. So how we calculate that, for instance, for hydric envelope turnover, we have looked the percentage of the current species distribution that is exposed to drought, so that will have moisture balance that will be outside what is the current range of the species. And we've done the same for climatic envelope turnover, so how much of the current range of the species will be outside the suitable habitat that we currently have. So here, just to give you an example, you have species like if you just look yellowbird, it's a species that will have a high turnover in its current range. Will have 40% of its hydric envelope turnover, and 64% is projected to be outside its current species distribution range in the 2071 to 2100 time period. If you just contrast with the white birch, it would be only 19% and 34% of the species range that will be outside its current hydric or climate condition. So there's really big difference in the exposure between species. So we think it's really important to include all this layer. It's really complex, and you have to include all this layer of information to get a better sense of what's happening. So that's what the type of work we tried after to do. We tried to integrate the ecological knowledge we have on tree sensitivity to these biophysical predictions of exposure with the climate envelope. So what we've done, we have integrated climate scenarios, drought impact with the climate moisture index from Ted Hug, a stem composition at Canada-wide, and an index of sensitivity based on species traits. And we've done that for each different stressors, really focusing on a really clear, concrete question, and all the layers have been developed really specific to that question. We can go, if you have more questions, these are things we can discuss, or the details also are in the ecosphere paper. So that's what it gives, these maps here. I can explain you a bit how this works. Yeah, okay. I have arrows on that, and that's good. So you have, this is a two-dimensional color-coded legend that is indicating the degree of exposure and sensitivity. So you have the both in the map. So in the x-axis is the exposure, where what you're seeing is the stand tree biomass expected to experience conditions below its current hydric envelope. So on the left of the axis, it's a low biomass that is outside this current hydric envelope, and yeah, okay, and yeah, okay, and yeah, it's not the distance I wanted to tell. Okay, and on the right axis in blue, if you have a high biomass, you have a higher biomass that is outside its current hydric envelope, and then the y-axis is the stand drought sensitivity that is based on the trait index that we have developed. And so if you go from, so you have a low, so green to, in the green you have a low stand sensitivity, and on the blue to the pink it's the higher sensitivity. So the hotspot of the vulnerability will be both high exposure and high sensitivity, which will be the pink area at the top right of the legend. So this map here is telling you a projection of the tree vulnerability to drought in Canada for the 211-240 projection. And then we've done that for 3 times projection. So we have here the 241-270, 2041-2070 here, and here for the 2071-2100 for the projection here. We've done the same work also for tree vulnerability to migration failure, where the x-axis, so we have combined exposure and sensitivity. Sensitivity here in this case is the stand migration capacity, with species having better migration capacity than others. So on the x-axis is the distance to a suitable climate habitat for species that is expected to experience conditions outside the current climate envelope. So when for a given stand you don't have the same climate current envelope for the species, where is the nearest suitable habitat? And on the sensitivity is the migration capacity, how good the species is to migrate. So we've done the same thing here for the 3 time periods. So you can see the evolution of the vulnerability to migration failure. So what's interesting here is to look at the 2 different stressors. So on the left you have the drought vulnerability, and on the right is the vulnerability to migration failure. And it's interesting to look at the vulnerability hotspot. So we'll be more on the pinkish color in the map, where you can see that they are differing according to the stressors under study. You will have for the drought, you will see it's more in the boreal, in the prairies, where you have more of this pinkish color. And if you look on for the migration failure, it's at that long time frame. It's in the Rockies, where at the beginning in the Rockies, the distance is really short because the species just need to climb up the mountain. But when you get that there's no suitable climate anymore in the mountain, the next suitable habitat gets really far after. So it's really interesting to contrast these 2 maps and seeing that they are different, between If you have questions after, we can discuss a bit more. I know I can spend a long time discussing these maps, but yeah, it might be better to go back for questions after. Yeah, okay, and then if you're interested as well, I think that's something that may interest some of you. We have also developed an interactive tool. These maps are available in interactive format tool where you can go on the map and you can either enter a coordinate or you can click on the map and you will have for a region, it's at the 2.5 kilometer grid cell resolution scale. You will be able to see the sand sensitivity in terms of the volume of wood that are outside the current hydric or you have both hydric and climate envelope, and also the sensitivity of the different species that are composing these stands. So that could be interesting to have. So with these maps, you can have the national but also regional insights of vulnerability. Yes, that's and then just to tell you that next week, we'll have presentation from Samuel Royer-Tardif that will speak to you about other work that is done in my lab about the adaptive capacity. So the other aspect that is less known one aspect really important of vulnerability assessment that will really tell us how species can persist with change and environmental conditions. So that will be another. So I invite you all to come to listen to this talk from Samuel. Thanks, and I'm already ready for the questions.
Great, thanks, Isabelle. So we have lots of time for questions. Again, if you'd like to use the chat box, please feel free to go ahead and type out your question there. If you're on the conference call line with us and would prefer to ask a question over the phone, all you're going to have to do is hit *6 and that will unmute your line. But I do see that we have some questions in the chat box. So Andrew Park has 2 questions here. The first is, which particular future climates are you aiming at, since many different scenarios are possible under different RCPs and different models?
Yes. Good question. Yes, sorry, I try to avoid a lot of details, so that's why it's good for a question, and also, we can even don't hesitate also to contact me after if you have any additional questions, because there's so many details in this presentation, in this work, so many layers of information. But in this case here, we work with the RCP 8.5, which was the more extreme scenario. And why we worked with this extreme scenario? Because this work is really intended to find some vulnerability hotspots. It's really to have where we should monitor more. It's really these maps are really designed to give us an idea of where we should look at, where we may encounter more rapidly some impact of climate change. So that's really the way they are designed. So that's why we wanted to have the more extreme scenario. Although the extreme scenario these days looks quite real, but so that's the one we used.
Great, thanks, Isabelle. Andrew's second question here is, if we're saying Aubin, for example, has a high adaptive capacity, does that also account for synergy between stressors such as drought and pests?
No, I will not speak too much about adaptive capacity. Andrew, I invite you to come to listen to Samuel's talk next week. But just to say, the way we work about adaptive capacity, and Samuel will tell you more about that. We were looking at the intrinsic adaptive capacity of species, but we are fully aware that we can develop for other aspects of adaptive capacity. That's all stuff we can do. But all the maps and the maps we have developed and all the work we have developed, we really started with a really concrete and really focused question. For instance, for the drought, we are really working on the map we showed is about, I forgot to tell that, it's about the mortality of adult trees. We're not looking on regeneration, failure, or any other aspect that could be related to drought. This is another question that will need other set of traits. So this is all stuff we are currently working on, that we can develop after. But we think these maps they cannot be catch-all. They need to be really focused on a really specific question. That's the way we develop this work. So yeah.
Great. So the next question here is from Gordon Whitmore. So is your information available in spatial files?
Yes, they are. You will have access. I would say first you should go see on the website, but please contact me and I will put you in contact with Laura Boisbernard that is working in my lab that can send you the files as well. There's some stuff we can share. So please just contact us and we can give you access to.
Perfect, perfect. The next question here is from Michelle Williamson. So were all the rankings based on expert opinion in workshops?
No, it's not based. The ranking is not based on expert opinion at all. That's really the unique aspect of our work. It's based on quantitative. It's really quantitative ranking. It's based on the traits. So the workshop was really the group of experts to say what are the key mechanisms and traits that will explain drought sensitivity. Let's say we will explain the species response to a specific stressors. And then with them, we really worked on with them and also with a lot of literature review, we developed some relationships. So we know, like, for instance, an easy one, rooting depth. More the species is root deep, more it will avoid a drought, you know. We have this kind of relationship. Also with the xylem cavitation, you know, relationship between xylem cavitation and drought resistance. We have all this information that that we know, and with that we were able to assess quantitatively the sensitivity of the species.
Great, thanks.
So the expert was giving us the knowledge to develop the framework, and then with them with literature review we were really able to develop a quantitative index.
Perfect, perfect. Okay, so the next question here is from Riley Morris. So have you done any work on impacts from changes in the forest fire cycle from increased droughts?
No, we didn't do this type of work, but we're working there with some people working on that, with Sylvie Gauthier and also with some people from our lab, not our lab, but our at Great Lake Forestry Center. And then we're starting working, the part, our lab, what we're doing is really adding the species response to. So what we are trying to work, and related to this aspect, is on the regeneration failure. So when you have this increased recurrence of the drought and of the fire, there's some species that are more sensitive to regeneration. So that's the piece of the work we are currently developing and would like to include to the exposure work that is made by Gauthier Lab and Chanley Lab as well from our center. So that's the type of work we're currently starting to work. We're working on it for a few years, but just not have time to finish yet. So.
Great, thanks, Isabelle. So the next question here is from Adjay Prado. So does the map of migration vulnerability consider the potential migration occurring between different time periods illustrated on the maps, or is it based on current distribution?
Yeah, that's really a limitation of the work. It's based on current distribution. So yeah, sure, further you're going up on the, with different time periods, further you are in it's based on current distribution. But we are doing other work I didn't present today, where we're looking at the actual capacity of species to migrate. So what we're doing, we're trying to refine. It's another approach, also using the traits. It's all based with these traits. We're trying traits and also a curve of the word is not coming to my head. Anyway, traits and other stuff. We're looking on refining these climate envelope to say, okay, that's the future climate and how fast the species are moving. And some species are moving faster than others. So we're getting, we're doing some modeling approach on that as well. But I didn't present today on that. So, but if you have questions, I can just maybe write to me and I can send you a bit more information about what we're doing right now.
Perfect, perfect. Okay, so the next question here is from David Restivo. So have you examined vulnerability due to changing temperature and precipitation bioclimatic variables?
Yeah, we started to work on changing temperature. trying to define sensitivity, differential sensitivity between species, but the knowledge was not ready yet to have a clear index with that. So this is the work we just put a bit aside. We hope to have a chance to work a bit more on that in the future, but that was the one that was harder to develop right now.
Correct. So the next comment here, actually, as opposed to a question, is from Marisa Costa Cabral, just about how we're on that trajectory for 8.5.
Yeah.
Bruce MacArthur, so would more detailed soils mapping influence your species predictions?
Yes, that's a really good point, and we have a scientist at GLSC, Kara Webster, currently developing some soil maps. We have a project where we're working more at the regional level, and we hope to include, we just wait that our product ready so we can use and adding the soil mapping into these predictions. That's a key point. What we're doing here, we're just integrating information that is available. And I think this is the same thing as when we're doing, when we are showcasing where we're missing information. That's a point really important. We should say we most of the time not taking a soil difference in our prediction, not because it's not important, it's just because the information is not available in the format that we can easily use in these models. So yeah, absolutely important, and we hope to do that in the future.
Great. So the next question here is from Andrew Park, sort of following on what Marisa had stated. There is a low probability, high consequence tail to the climate sensitivity curve in which global temperatures could increase beyond the RCP 8.5 average, with global temperatures increasing 5, 6, or more degrees. So is there any chance that you might explore this catastrophic possibility?
As I told you, I'm not a specialist in some of this aspect, and this is one aspect I'm not specialist. We're working working with Dan McKinney in this work, but we think for the work we've done here, the RCP 8.5 is a good one to. I fully agree. It's not the most extreme, but it's one of the extreme that we can use as it gives some good indication. Yeah, we can use several models, and I think that's really important. But the type of work we're doing here is kind of more of a core scale to give some general indication of where are the hotspots of vulnerability, and I think we're good with that. We are working, with experts that are doing this type of work about the climate modeling, and us we're just adding the ecological knowledge to it. So I'm using their call on that.
All right, thanks, Isabelle. The next question here is from Melissa Spearing. So how detailed FRI data or inventory do you require for assessing forests in Southern Ontario? She had read in your paper that there was limited inventory for assessing conservation needs of Carolinian species. And then also the comment underneath is from Michelle, kind of commenting on Melissa's question there.
Yes. That's the thing. More detail is the inventory, better the information is. For now, we're working at the scale of Canada. It's a key challenge, and this work would not have been able to do this work without André Baudouin, who have created these maps, where they integrated information from the different provinces. But sure, the level of information is coarse, right? But it suits the type of work we're doing because it's a coarse assessment at the scale of Canada. But we are also working, for instance, we have an example, we're working at the Petawawa Forest Research, where we're working at a really smaller scale and using the same approach. So maybe something we may want to discuss more in details, Melissa, because having access to some really good inventory data, it depends, the scale, we need to be at the species, just to answer more directly to your question, we need species, really information about species, it's really at the species level. So the problem we have sometimes is that in some area it says you have shade intolerant species. It's kind of, they put or they would say even deciduous, So when we got this kind of information, we're kind of stuck. We need to work at the species level. But if you have any information about stem per hectare or any kind of level of information, here we're working with the biomass, but we can work at with different variables. Better is the data, better we're able to do the assessment. So if you have some interesting data set, then we'll be more than happy to collaborate to do some mapping at another scale with using this approach. Now the approach is there. What's happening with the Carolinian species, we will need also to document some species. It's just a question of time, just document this. Now we have about 30 species that are documented to do the analysis. When we work in Carolinian species, we need to add far more species. So it will have a work on documentation, but this is not unfeasible from us. We look forward to document those species because many of them are also projected to go more, we hope, going more north. So that would be an interesting, so we'd be more than happy to work on that. So please write to me and we can have a chat on that.
Great, thanks Isabelle. So I'm just going to take James' question here first, and then I'm going to go to the phone lines and see if there are questions there. So did you consider geographic or topographic barriers to species migration?
No, not in this. No, not in this work. But that's sure. It's another. This is another layer. If we have this layer available, and we can just add it in the analysis and just constrain the analysis with that. That's another thing we can. That's just adding layers of information into it. So yeah, but no, we didn't make it. That would be good to do.
Perfect. So let's go to the phone lines. If there's anybody that would like to ask a question over their phone, just hit *6 to unmute your phone line. Okay, if none there, Frank Johnston's question here in the chat box, does beige indicate persistence in place? I'm not sure.
Yes, I forgot to say a lot of things, Yeah, exactly. So I will just point what he's telling about the beige. A lot of details I forgot to say. Too many things to say with them. That's the thing, when you work too long on a project, you forget to tell all these things. So these colors here, you see this beige here, all here. So it means that the species, are currently staying. So all the region in beige is where we have the data we were working on. So the white, it's considered unforested, So in the beige, the species were staying within their current climatic or hydric envelope.
Okay, Rita's
so
question.
You were right.
Rita's question about what does the white? I think that's unforested.
Yeah, exactly.
Okay. Well, I don't see any more people typing in the chat box, so we'll just give everybody a couple more minutes here to maybe ask some more questions of Isabelle. Last call for a teleconference line, if there's anybody that would like to ask a question there. And if not, Isabelle, I think everybody has your email, and if not, I'm going to send a follow-up email to everybody who registered, and I'll CC you so everybody will have your contact information.
Yes, that would be great. I know there's a lot of information I didn't tell, so please don't hesitate to contact me directly, and we'll send you the information.
Okay, great. So since there are no more questions, we'll wrap things up here. So I'd like to thank everybody for joining us today for the FACoP webinar. And please make sure to register for Samuel's presentation next week so that you can hear more about adaptive capacity. So with that, I'd like to extend a very, very big thank you to you, Isabelle, for your time and effort and for a great presentation. Any last comments from you before we log off here?
No, that's all. Thank you, everyone, for your time, and it was great to have a chance to chat to you about this project.
Yeah, well, it was great having you, and thanks again, everybody, for joining in and for your great questions. That's it for today, and hopefully we will catch you next week during the other part 2 of this webinar. Thanks, everybody. Have a great day. Bye, Isabelle.
Bye. Thank you.